Okay, in this section 8-3, our topic is going to be area of circles. Now, many of you are familiar with the formula for area of a circle. It's area equals pi r squared. R stands for radius. So if you know the radius of the circle, which remember is from the center of the circle to the outside edge, then if you know the radius, then you can square it, multiply it times pi, you got the area of the circle. So like for example on this one, we can go area equals pi times 5 squared, and of course typically you've been taught to take that and just kind of put it into a calculator, right, and get pi times 5 squared and turn that into a decimal, which will be 78.54. However, really beginning with geometry and the mathematics courses beyond geometry, you're more and more going to see an answer like this expressed in terms of pi. And so really what we want to be looking at in this section for our answers to come out to be is going to be in terms of pi. So if you do 5 squared and get 25 and multiply 25 times pi, we can just express our answer as 25 pi. So like I say, just leave your answer in terms of pi for this section. Of course, this is more exact than this because this is a rounded answer is the reason. All right, so just a little more practice at that now. So let's say I've got another one where my radius is 10. So again, its area equals to pi times 10 squared, which means the area is going to be 100 pi. And of course this one where we've got area is equal to pi times, now don't forget r stands for the radius, right? So don't be tricked by this. This is the diameter. Diameter is all the way across and the radius is halfway across. So if the diameter is 18, my radius is going to be 9. So that's one that trips students up quite a bit. And so then my area would be 81 pi. Okay, so here's one thing too that I want you to make sure you understand. Like 81 pi and 81 are not the same thing. 81 pi is a little more than 3 times as big as 81. Okay, so you can kind of see that in this example right here. 25 pi is 78.54. Okay, so just remember 25 and 25 pi is not the same thing. Keep that in mind. All right. Now, where are we going to be going with this? Okay, so what we're going to be doing is we're going to be taking this formula for circle and certain other figures that we have learned in the previous 2 sections. And what we're going to do is we're going to be asked to find the area of the shaded region. And then also in the directions it says all polygons are regular, which means, remember, that a regular polygon is one where all the sides are the same length and all the interior angles are the same. All right, so we want to find the area of the shaded region, right? So let's take a look at this figure. What we've got is we've got 2 circles, right? And the shaded region is outside of the first circle, but inside of the larger circle, right? So the shaded region's outside of the small circle, but inside of the large circle. So the question is, how are we going to find the area of that shaded region? Okay, so here's the tactic, okay? The procedure is going to be to find the area of the large circle and subtract off the missing space. So you can find the area of the entire circle, but then subtract off the missing space, which is the area of the small circle, and then you would have the area of the shaded region. So we need to find the area of the big circle. So remember the formula, area equals to pi r squared. So we're going to find the area of the big circle first. Pi times, now we need the radius of the big circle. Well, from here to here is 5, and from here to here is 5. The radius of the whole thing is 10. That'll be 10 squared. And so the area of the big circle is going to be 100 pi. Now let's find the area of the small circle. So area is equal to pi r squared. So my area is going to be equal to pi times, the area of the smaller circle is 5. And so the area of the smaller circle, 5 squared is 25. And so we'll have 25 pi as the area of the smaller circle. Okay, now, remember, we're trying to find the area of the shaded region, and remember what we said our tactic was going to be. We're going to find the area of the large circle, 100 pi, and subtract off the area of the smaller circle, 25 pi. So what do I need to do with these two numbers? We need to subtract 100 pi minus 25 pi. And remember, 100 pi minus 25 pi is 75 pi. Again, leave it in terms of pi. So remember, you can subtract pi's from each other just like you can subtract x's, right? So 100x minus 25x is 75x. So 100 pi minus 25 pi is 75 pi. And then that is your answer for the area of the shaded region. All right, so our strategy here is going to be the same for these problems. You want to find the area of the whole thing and subtract off the area of the missing space. All right, so let's look at a few more problems here. Here's the next one that we've got. Okay, I've got 3 circles this time, 1 larger circle and 2 smaller ones inside of them. All right, and so when I come up with a strategy for this one, then I need to find the area of the larger circle, and then once again subtract off the area of the 2 smaller circles. All right, so let's start by finding the area of the large circle. Area equals to pi r squared. So my area is equal to pi times. Now, we need to look at the figure and try to figure out what is the radius of the large circle. All the way across the diameter is going to be 8, so that means the radius is going to be 4, so that'll be 4 squared. And then, so that's going to make the area of that big circle 16 pi. All right. Now, let's see if we can find the area of the smaller circle. So area, which equals to pi r squared, which, by the way, one thing that we want to make a note of here is, remember, if all the way across is 8, halfway across is 4, and then so this is 2 plus 2 plus 2 plus 2 to add up to 8, which means that the radius of both of these smaller circles is the same. So these two smaller circles are the same size is what we're getting at. So if I find the area of one, I already have the area of the other one as well. So area is equal to pi times. So what is the area or the radius of one of these smaller circles? It's going to be 2. So that'd be 2 squared. So that means the area is equal to 4 pi. All right? Now, let's see how we can come up with the answer. Again, I want the area of the whole thing, 16 pi, minus the area of the empty space. Well, remember, one of these circles has an area of 4 pi. That means if I wanted to subtract off 2 of them, then I would have to multiply 4 pi times 2. So if this one is 4 pi, right, and this one has an area of 4 pi, altogether I'm subtracting off 8 pi, double that amount, because I've got 2 of those circles, right? 2 circles whose area is 4 pi, it means that the area of both of them together is 8 pi. So what is 16 pi minus 8 pi? 8 pi, and then that is your correct answer. All right, so that is going to be the area of the shaded region. All right, let's move now to the next figure and take a look at what we've got here. So here I've got a circle inscribed inside of a square. A circle inscribed inside of a square, and the shaded region is outside of the circle but inside of the square. All right, so let's see how we're going to attack this one. So again, we want to find the area of the whole figure and subtract off the empty space. Well, what's the whole figure? Well, the whole figure is a square. We've already learned how to find the area of a square. It's length times width. And so that would be 10 times 10. Because remember, in a square, all sides are the same. And so that's going to be equal to 100. So the area of the whole thing is 100. Now I need to subtract off the empty space. Well, the empty space is a circle. What's the formula for area of a circle? Pi r squared. All right, so I've got area is equal to pi times the radius. In this case, if all the way across is 10, my radius is going to be 5. So it'll be 5 squared. And so I know that my area here is going to be 25 pi. All right, so the area of the square is 100. The area of the circle is 25 pi. What do I need to do with these two numbers again? I need to subtract them. 100 minus 25 pi. And once again, we'll leave our answer just like this. We won't have to convert it to a decimal. There is your answer. All right, let's try the last one here now. So once again, I've got a figure that I need to find the shaded area of. This time the roles are kind of reversed. Last time we had a circle inside of a square. Now we've got a square inside of a circle. All right. However, the idea is going to be the same. I need to find the area of the whole thing, which is the entire circle. So that's going to be area equals to pi r squared. Area equals to pi times, we can find the radius pretty easy, 6 squared. So the area of the entire circle is going to be 36 pi. All right? So there we go. Now, we need to find the area of this square. Now remember, the area of a square is length times width. Okay, I've got half of a diagonal of this square. All right? And so there are two ways actually to do this problem. The more work way and the less work way. The more work way of doing this would be to draw a right triangle in here, right? Make this 6, make this 6, and use the Pythagorean theorem to come up with this side, and then do that side times that side and come up with the area. That's a lot of work. There is an easier way, and the easier way is to remember this. Okay, a square is also a rhombus, right? So remember that from Unit 6. So since a square is also a rhombus, and remember in 8.1 we learned about a formula for the area of a rhombus, which is 1/2 diagonal 1 times diagonal 2, we can use this formula and find the area of this rhombus instead of using the formula for area of a square, because it's easier for us to get the diagonals than it would be to get the length and the width. That's the reason. Okay, so I can now put area equals to 1/2 times diagonal 1 is 6 plus 6, 12. Diagonal 2 is 6 plus 6, 12. Because remember, in a square, the diagonals are the same length. So now my area is going to be actually half of 144, which is 72. So again, the reason why we can use this formula is because remember, a square is a rhombus. So I could use the formula for area of a square and get length times width. That's the long way. Or I could use the formula for area of a rhombus that we learned in 8.1 and do 1/2 the diagonal 1 times the diagonal 2, which is the shorter way of the two methods. All right? And we're not quite done. We actually have to subtract this off. 36 pi minus 72, and then that's your answer. Remember, the reason why you can't combine these is because they're not like terms. They either both have to be pi, like they were here, to subtract off, or they both have to be regular numbers to subtract off. So since one's pi and one's a regular number, you just leave it like that, and that is your answer. So at this point, you're ready for quiz 8-3.